Hello, my name is Leos Cseppentő, and in this video I would like to show you how to use the symbolic execution-based test evaluator framework, also known as SETTE. In the previous video I have shown you how to install the framework. SETTE is being developed at the fault-tolerant research group at Budapest University of Technology and Economics, Hungary. You can find more information about SETTE at SETTE-Testing.github.io. Now let's start SETTE. Upon start, SETTE writes out its configuration and also informs us that two tools were not found. If the configuration file is not correct, SETTE will exit with an error message. The main idea behind SETTE is to call different test input generator tools to generate test inputs for short codes, which are called code snippets. We have written 300 of them. I will show you one of them, how it looks like. So let's open the file manager, open our SETTE directory, open the code snippets, check the source codes, and we need the source of the snippets. The example will be the linear expressions, which is in the conditionals category. Now let's open the file. This Java class is called code snippet container because it contains several code snippets. The desired statement coverage is indicated for each code snippet in an annotation. For example, the name of this code snippet is 2params_int and it awaits 2 integer parameters. In this case, the test input generator tool have to solve this two-variable equation system in order to reach maximal statement coverage. SETTE is able to evaluate all the code snippets on one tool at a time and currently supports 3 different tools. In order to perform an evaluation, you only have to execute the first 5 scenarios in order for each tool. In this tutorial, as I said formerly, we will carry out an evaluation for Symbolic Pathfinder. First, let's call the generator in order to create the Symbolic Pathfinder specific test drivers and configuration files. If you open the file manager and browse for our SETTE directory, you can see that a new directory SETTE results has been created. This directory will contain all the outputs created by SETTE. Now as you can see, there is a new directory created for Symbolic Pathfinder, and here you can find the generated files. You can see that the Java source file and the GPF configuration file was generated for each code snippet. The test driver is quite simple in this case. It only contains a main function which calls the code snippet with the default input. The configuration file contains several settings, for example the test driver, the code snippet, and the SMT solver. Now as everything is ready for Symbolic Pathfinder, go back to the terminal, start SETTE again, and call the runner phase. The runner builds the previously generated project and it starts executing the tool for each code snippet. This is the most time-consuming part of the evaluation. The test input generator tool is called for 300 different code snippets, and several of them will need more than 10 seconds or even reach timeout. Now the runner phase has finished, and I will show you what kind of files have been created. There is a new directory in the SETTE snippets Symbolic Pathfinder directory called runner out. There is a detailed log about the runner phase. And there are several files for each code snippet. Let's search for our example 2params_int. And as you can see, there are 2 files. The info file contains the executed command, whether it finished properly, whether it was destroyed, for example if it reached timeout, and the elapsed time. The out file contains the raw output of Symbolic Pathfinder. In this case, it consists of this initial configuration, debug information and constraints, and the generated inputs. As you can see, in this case, Symbolic Pathfinder was able to produce such inputs which covered both the true and the false branches of the condition, and it solved the linear equation system correctly. The next step, to start SETTE again and call the parser phase. The parser phase parses all the raw outputs in a common XML format. As you can see, a new file appeared for our code snippet. This input XML file contains the generated inputs. As you can see, in this case we have 3 pairs of inputs. The structure of this XML file is same for all the tools. As you can see, the result for this code snippet execution is S. This means that the execution was successful, but we don't know yet whether the required coverage was reached. In order to determine the reached coverage, first close the file and call SETTE again. Now run the test generator scenario. We can check the files. A new test directory was created, which contains the source code of the test cases. For our code snippet, it looks like this. In this file there are 3 different unit test cases. Each of them calls the code snippet with an input. This generator test suite allows us to measure the reached coverage with Jacoco. The SETTE framework can decide whether the required coverage was reached. In order to do this, run the tool again and call the tests run phase. There might be some exceptions, but you don't have to deal with them. Now, let's go back to the runner directory. Conditionals, 2 params int, and we will need the linear version. There is an HTML file. If you open it, you can see that there are green lines for all the lines of our code snippet, so each line was covered. If you open the coverage.xml, you can see the fully, partially, and not covered lines in the class. These are the fully covered lines. We don't have to deal with the other lines because they are code lines of other code snippets. Now we are done with evaluation, but we have a lot of files. To have a quick overview about the evaluation results, SETTE allows us to export them. Now let's open this file. We can apply a filter for the table and, for example, search for all the cases when tool execution resulted in an exception. Now you can see the code snippets which caused the Symbolic Pathfinder to fail with an exception. Thank you for watching. If you are more interested in SETTE, please visit the project website at settetesting.github.io or read our paper. If you have any questions, please don't hesitate to ask. Goodbye.